Welcome to this video on the Automic Automation Google Cloud Storage Integration Solution. In this video, we will explain the Google Cloud Storage Integration and what it brings to the Automic Automation user community. Google Cloud Storage, GCS, is an object storage service that allows for storing, accessing, and manipulating data in the cloud. GCS storage is a fundamental component for a multitude of workflow processing use cases. Being able to successfully manage these objects is essential for any automation success. The Automic agent for GCS integrates GCS object management with enterprise workload automation, enhancing digital transformation. This integration provides end-to-end visibility, centralized control, alerting, SLA management, reporting, and auditing. Integrating Automic automation with Google Cloud Storage allows you to run Google Cloud Storage jobs in your workspace from Automic Automation. We'll provide some technical insights so that the integration components are clearly identified and the deployment sequence is understood. We'll focus on the configuration of the agent and the design of the two core object templates, connections, and jobs. Finally, we'll run through a demo. Automic automation plays a central role in orchestrating operations across multiple environments, including the cloud. Automic automation synchronizes these processes with other, non-cloud operations. By integrating Google Cloud Storage, we can configure process automation centrally in Automic Automation and then trigger, monitor, and supervise everything in one place. Google Cloud Storage processes can then be synchronized with all other environments routinely supported by Automic Automation. Google Cloud Storage's role is reduced to execute the jobs. All other functions, especially those pertaining to automation, are delegated to Automic Automation. This means that we don't have to log into the Google Cloud Storage environment and keep on refreshing it by ourselves. Automic Automation manages all the execution and monitoring aspects. The Automic Automation integration provides a simplified view to Google Cloud Storage jobs. Automic Automation lets us build configurations with intuitive interfaces like drag-and-drop workflows and supervise processes in simple dashboard tools designed natively for operations. Statuses are color-coded, and retrieving logs is done with a basic right-click. From an operations perspective, Automic Automation highly simplifies the configuration and orchestration of Google Cloud Storage jobs. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workload. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workload. A conventional architecture involves two systems, the Automic Automation host and a dedicated system for the agent. The agent is configured with a simple INI file containing standard values: system, agent name, connection, and TLS. When we start the agent, it connects to the engine and it adds two new objects to the repository: a connection object to store the Google Cloud Storage endpoint and login data, and a job template designed to trigger Google Cloud Storage jobs. Let's assume we're automating for 4 instances of Google Cloud Storage. We create a connection object in Automic Automation for each instance by duplicating the con template for each of these instances. Lastly, we create the Google Cloud Storage jobs in Automic Automation for each corresponding process in Google Cloud Storage. The Automic Automation jobs include the connection object based on the target system. When we execute the jobs in Automic Automation, it triggers the corresponding process in Google Cloud Storage. We're able to retrieve the successive statuses, supervise the child processes in the cloud, and finally generate a job report. In Automic Automation, this job can be incorporated in workflows and integrated with other, non-cloud processes. The procedure to deploy the Google Cloud Storage integration is as follows. First, we download the integration package from Marketplace. This package contains all the necessary elements. We unzip this package, which produces a directory containing the agent, the INI configuration files, and several other items, like the start command. We use the appropriate INI file for our specific platform. Google Cloud Storage is a standard Automic agent. It requires at least 4 values to be updated: agent name, Automic system, JCP connection and TLS port, and finally TLS certificate. When the agent is configured, we start it. New object templates are deployed. we create a connection to every Google Cloud Storage instance we need to support. For this, we use the template con object, which we duplicate as many times as we need. The con object references the Google Cloud Storage endpoint. Finally, we use the Google Cloud Storage template job to create the jobs we need. We match these Automic automation jobs to the Google Cloud Storage jobs, reference the connection object, and run it. We're able to supervise the jobs and their children, generate logs, and retrieve the statuses. The jobs can then be incorporated into non-cloud workflows. We install, configure, and start an agent to deploy the Google Cloud Storage integration. The agent is included in the Google Cloud Storage package, which we download from Marketplace. We unzip the package, which creates a file system agents/Google Cloud Storage/bin that contains the agent files. Based on the platform, we rename the agent configuration file ucxjcidx and set a minimum of 4 values: the agent name, the AE system name, the host name and port connection to the automation engine's JCP, and finally the directory containing the TLS certificate. Finally, we start the agent by invoking the JR file via the Java command. The agent connects to the AE and deploys the object templates needed to support the integration, the con or connection object, and the Google Cloud Storage job. In our demo, we will create a connection object. Once we have established the connection to the Google Cloud Storage environment, we'll create a Google Cloud Storage job. Finally, we'll execute and supervise the job. Welcome to the Google Cloud environment. Here, we have a search option that includes a cloud storage feature. By clicking on it, you can see all the buckets. These are the buckets. If you open one of these buckets, you can see several folders. For the demo purpose, we have created 2 folders here, Demo Desk and Demo. Let's move on to the Automic system. Here, we create a connection object with specific inputs to connect to Google Cloud Storage. First, we must specify GCS as the cloud storage type. Then we must enter the endpoint, which is the URL of the Google Cloud Storage environment to which you want to connect. Next, we specify a credentials method from the drop-down menu. Currently, we support the service account key, which you can provide directly as JSON or via a file path. We select the file path input type and specify the location of the file that contains the authentication information for loading data into Google Cloud Storage. Optionally, in input type, we can either type a JSON or specify a JSON file that is stored on the agent machine. If you are using a proxy in your environment, you can specify the proxy hostname, port, username, and password in the proxy section. Once the connection object is defined, you can create Google Cloud Storage jobs. There are several options. Some of them are self-explanatory, like upload, download, delete, and copy or move jobs. We will now focus on the download job and explain the specifics of the monitor and exist jobs later. The download operation involves downloading the file from the bucket to our local system. The connection drop-down list lets us select the appropriate connection object. Optionally, you can also specify the region where the service is located. Next, we have the Use regex option. This option is not selected by default. Select this checkbox if you want to download multiple files at a time with a regular expression. In that case, you must provide the bucket name and source to fetch all files matching this source. However, for this example, we are not selecting the Use regex option. We can now select the bucket name from a list of available options in the Picker dialog. Also, we can select the source file path from a list of available options in the Picker dialog. Next, we specify the destination file path, which indicates where on your local system we want to download the file. This field is only available because we have not selected the Use regex option. The query parameters field is optional, and we do not use it in our example, so it remains empty. The failed operation parameters section allows you to define if you want to try to execute failed operations again or not. Select the retry checkbox, and if the operation fails, you can specify the number of retry attempts and the delay time in seconds between the attempts. Here, we set this delay to 2 seconds. Next is the file permission parameters section. Here, you define the parameters that determine who can access and modify the downloaded files and which permissions they will have. These file permissions differ depending on your operating system, OS. Those OS differences also apply when you grant permissions to a user different from the one running the job. For Windows, you can define the file permissions read R, write W, and execute X. Any combination of these values is allowed in uppercase. For example, you can use the spelling RWX as seen in the screenshot, or just RW or R,W,X. For Unix, each file is associated with an owner and a group and assigned with permission access rights for 3 different users: file owner, group members, and others in that order. Specify the file owner of the downloaded file who will have the specified permissions, and file owner group as specified on your Unix environment. This group will have the specified permissions. In case of invalid permission settings, you can choose to either fail the job or allow it to succeed. For this example, we will choose to fail the job. Everything is configured now, so we execute the job. Let's go to the executions view. This is the list of executions in Automic Automation. As you can see, we have already run some jobs. The details pane shows the status field, which tracks the job status in the target environment. The job has ended normally. The details panel also shows an object variable called and list of downloaded files hash and number of downloaded files hash. These variables show the list and the number of files successfully handled by the job. Let's have a look at the reports. The report captures the response we received, showing the source file and its destination. The agent log is an additional report type that captures everything related to the job execution from the Automic Automation perspective. It lists all the connection details, followed by the job inputs and execution logs. Finally, we see that the file was downloaded successfully. This is the name that we have provided. Let's check the file status on the local system. Here, you can see that the file has been downloaded successfully. Now, let's take a look at the specific parameters of a monitor file job, which allows you to monitor a GCS bucket and check if files have been created or updated in the bucket. Again, the parameters you need to define are similar to those for the previously explained download job, with the difference that you see a monitor job type field, where you select the job type you want to monitor in the specified GCS bucket. You have 3 options. Create allows you to monitor whether the file specified in the file name has been created in the bucket. Update monitors whether the file specified in the file name has been updated in the bucket. And Generate lets you combine the monitoring capabilities of the create and update types. You can use this type if you are unsure whether the file is already available in the bucket. In either case, the job keeps track of the file once it has been either created or updated until the time you specify in the steady state field has elapsed. Only then does the job send a positive response. For this demo, we define create as the monitor job type. We select the bucket name from the list of available options in the picker dialog and define the optional region field to limit the data we get. Next, we define the file we want to monitor. In our case, it's called demo/demofile1. JSON. We check the regex box, which opens a new field called sorting. Here, you can select the sorting order for the file names the job will return. The default setting, native sorting, stands for no sorting order. You can also choose alpha ascending and alpha descending, where the files are sorted alphabetically by file name in ascending or descending order. You can select time ascending or time descending, where the files are sorted by their last modified time in ascending or descending order. Or you can select size ascending or size descending, where the files are sorted by their file sizes in ascending or descending order. In this job, we use the default setting native sorting. We set a steady state of 1 second and the sleep interval to 1 second, thereby determining the time before the monitor status request is resubmitted. We define the query parameter section with max keys equals 1000 to filter the query and the query response. Lastly, we check the return file URI box because we want the execution details to include the complete URI of the file name. Otherwise, the details would return only the file name. Now let's start the job and open the executions view. The job has ended okay. The details section shows the object variable called and file_URI hash with the complete URI of the file name we received from GCS because we had checked the file URI box. Let's open the job report now. The agent log shows the connection information and all the parameters we have defined. We have selected Create as the monitor type. Because we activated the return file URI checkbox, the log file now includes the complete URI of the file name. The job monitored this file until the time specified in steady state had elapsed, and then it sent the response that it had completed monitoring successfully. The last job we want to explain in this video is the exist file job. This job lets you check if a file exists on the GCS bucket. Again, the parameters you must define are similar to those for the previously explained download and monitor file jobs. On the exist file job section, you define the parameters relevant to run that job on the GCS system from Automic Automation. For our demo, we have defined the connection, the region, and the bucket name. We have also specified the file name that should be watched on the bucket, and we checked the use regex box because we want to use regular expressions to watch multiple file names. The retrieve file names field will only be available after you have checked the use regex box. We check this box to have the names of the files that match the regular expression, that is, the files found by the job, printed to the job report, REP, in a format that is easily parsed. Regardless of what you set here, the files that are found by the job are also listed in the agent log, plog, report. However, if you select use regex and do not select retrieve file names, the job report, REP, will be empty even if the regular expression finds matches. You can still find the file names in the agent log, plog, report. The query perms section again allows us to filter the query and the query response. For this job, we define max keys equals 1000. Let's run the job and check the execution section. The job ended OK. We now open the details section, showing that the job has ended with the status ended OK. The object variables section includes two variables, and file_count hash with the value 1 because the job has found one matching file. This variable is available because we had the use regex option selected in the job configuration. The end file_exist hash variable with the result true. It indicates that the file exists. Let's open the job report now. The report shows the file name we had defined that should be watched. The agent log shows the same information as for the other jobs. The connection information and the parameters we defined, the execution information, the response that the file exists, and a successful job end. That wraps up the demo on how Automic Automation can integrate with Google Cloud Storage to execute and monitor various jobs. Thank you for watching this video.